Welcome back. In our case now we have two functions, f and g, but first let's talk about g. G is defined as x minus 2 over x plus 1. So clearly its domain is r minus 1. Okay, so or we can write it as minus infinity minus 1 union minus 1 plus infinity. Okay, and we define f of x as g of the absolute value of x. We want to find the domain of f and also graph it. So we're going to graph it with f. We're going to graph both f and g. Okay, here what's the domain of f? Okay, the domain of f is, this is a composite function. Okay, so here to have f defined, we need to have, so the domain of f. Okay, so it's the set of x's in R such that the absolute value of x is different from minus 1. Okay, and we know that the absolute value is always bigger than 0. Okay, it's never going to be minus 1. Therefore, this is always true, no matter what value we give to x. So here we're going to have the absolute value of x is different from minus 1. And therefore, so we can say since we have this condition, the domain of f is R. Okay, but the domain of g is what? As we said, it's minus 1. Okay, R minus 1, R minus 1. Okay, so here we can graph this one easily, and we can see what we can do to graph f. Note that f of minus 1 or minus x is just g of the absolute value of minus x, and the absolute value of minus x is just x. Therefore, we have f of minus x is simply f of x. That means our function is even. Okay, so what we can do is we can graph g and take its symmetric with respect to the y-axis. But we're gonna graph all g. Okay, so here g is not defined when x is minus 1. It has, okay, so let me write it here, x minus 2 over x plus 1. Here it's not defined when x is minus 1. So we have an asymptote here. So this is x minus 1. And also we have this limit. Okay, so y equals 1. So it's the limit when x goes to plus or minus infinity. And when x is 0, we have minus 2. Its value is minus 2. When x is 1, its value is minus 1. And it's 0 when x is 2. Okay, so here, and the limit when x goes to minus 1 from the right is minus infinity. So here we can easily graph our function, and we take its symmetric with respect to the origin. Okay, here, so we have the graph that's gonna look like this. Okay, it's gonna be symmetric. Okay, so it's almost the same. It's not exactly the same, but you need a calculator to make it look alike. So what interests me is that here this is my g of x. So here this is the graph. So this is the graph of g of x, which is x minus 2 over x plus 1. So it's this part plus this part here, union this part here. So now I'm gonna graph f of x, which is g of the absolute value of x. Okay, so since it's the same as when x is bigger than 0, f of x is just g of x. So it's here. So I'm gonna draw it close to g. So f is close to g. It's the same thing here, but I'm making it close so you can see the difference. Now, when x is less than 0, I will make the symmetric with respect to the y-axis, which is this one here. So this is my y-axis to make it even. So I'm gonna do something like this. So here, this is okay. So here, this is -1, this is -2. So I think it's gonna be something like this. Okay. So this is my function. So this is f of x, and it's defined everywhere. Okay. G of x is defined on R except on -1. So here we see that this function is even. Therefore, the action that we can do is when we apply the absolute value here, we apply the absolute value first, and after that we apply the function, we get an even function. Or we can say that g of the absolute value of x is a transformation that makes the function even. Okay, so it keeps it at as it is when x is positive, but it takes the symmetric with respect to the y-axis when x is negative, as we can see here. Okay, and we have to pay attention to the domain. Note that g is defined for all the real numbers, but f is defined for all the reals except -1. Okay, therefore they don't have the same domain of definition. Okay, so this is the action of an absolute value on this kind of behavior of functions. Okay, so I think that's all we need here. We defined the domain, we found the domain, we said why is it like that, and we have the domain of f from of g from its expression here, and this means that we have finished the problem. So we found the domain and we graph it, and we graph f. Find the domain of f and graph it. So we found the domain of f, okay, so it's R, and we graph it. Okay, if you see any errors or mistakes, please let me know. Thank you.